And I'll call this the quadratic or even polynomial function. Ooh, sorry, make that a little smaller. Now, when we plot this, what ends up happening is I'm going to plot -2, -1, 0, 1, and 2. I'll use 5 values. When I put -2 in here and square that, it becomes a +4. A -1 will become -1 times -1 being 1. 0 is just 0. 1 will become 1, and 2 squared is going to give you 4. So when I plot this, I'll plot -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. And I'm just plotting enough points that I can get the shape of the function. Okay, and so this is a very common one that we've used a lot. If you look at the domain, I can plug any number here in for x. So my domain is x such that x is an element of the real numbers. My range, however, is everything above the 0. So it includes the 0. This is at 0, but everything else is above it. So our range on this is y such that y is greater than or equal to 0. And that way, every x that we put in will be within this range. Okay? Our fourth function is the cubic or the polynomial odd. Move up to that. Do something very quickly. The polynomial odd function, I'm going to use x cubed, but this could also be x to the 5th, 7th, 9th, any odd number. So this is the cubic or polynomial odd function. So y would also equal x cubed. Now, when I plot this one, I'm going to see some odd things. So I'll plot -2, -1, 0, 1, and 2. When I cube -2, I get -2 times -2, which is 4. And then 4 times -2, which gives me a -8. So I get a negative number back when that's an odd number. -1 will just give me a -1. 0 is 0. 1 times 1 times 1 will be 1. 2 cubed is 8. So when I plot this function, it will look like this. 2 will go way up, and this will be at -1, and then the -2 goes way down. So my function has kind of a funny little jig here. And that's what a cubic function looks like. Now the domain for this, again, I can add any number in. So my domain is x such that x is an element of real numbers. My range, this is going to go out. It goes out slowly, but it will go out forever. And so my range is also y such that y is an element of real numbers. So those are my first 4. Now we're going to move on to ones that are a little less common as far as your knowledge of them, maybe the shape. The first one I like to go to is the square root, and that's just the square root of x. So f of x equals the square root of x. When I plot this one, I will look at -1, I'll look at 0, 1, and I'm going to look at 4. And the reason I picked 4 instead of 2 is because I know the square root of 4, and I want to make the plotting easy. So if I put a -1 under here as the x, I don't get a number. I get a complex number or imaginary number back. So this, I'm going to just write DNE, which means does not exist. Put a 0 under there, I get a 0 back. I put a square root of 1, it's going to give me 1, and the square root of 4 will give me 2. So my function is going to start at 0, 0, because everything back here does not exist. When I put in a 1, I'll get 1 back. When I put in 4, I get 2 back. So this is going to look like this. Okay? So our domain here is going to go from 0 forward. Okay, so our square root function